Geometry, Unit 1, Section 6, the mid-segment. Construct a mid-segment. What is a mid-segment? Well, in the previous video, we learned what a median was. A median goes from an angle to a midpoint. Or I shouldn't say goes from, it really connects them. There's not really a direction there. Connects an angle and a midpoint. A mid-segment connects two midpoints. So angles aren't involved. Connects two midpoints. So it's a mid-segment connects midpoints. So if I know what the midpoint of AB is, and I know what the midpoint of AC is, and I connect those two, that's a mid-segment. Now, how do I draw one? Well, just like the median, you have to know where the midpoint was. So really, the construction is all about finding midpoints, and that's exactly what we did in the last video. Was we found the midpoint and connected it to an angle and drew a median. Well, if we find two midpoints and connect them, that's our mid-segment. So it's, once again, the perpendicular bisector construction is what we use to find midpoints. So it's really just more of that perpendicular bisector construction, which we told you was really probably the most important construction because it's used in so many different things. So I want to find the midpoint of AB. So like we've done many times already, I'm going to approximate about halfway, extend a little bit further than that, and draw my arcs. Flip it around. Same thing. Little points where they cross. Here, here. Get a line. Draw it. And right there. My line's green. That's okay. I'll draw that in green. But again, just like with the centroid, I don't care that this is a perpendicular bisector. I just care that right now it's going through the midpoint. It's bisecting AB. And so that's the midpoint of AB. And let's call it point D. All right, I need to do the same thing for another side. Let me do it on side AC over here. So I'm going to find the midpoint now, side AC. I don't need it to be that big. It says it's probably about halfway. Go a little bit bigger. Maybe some blue arcs this time. Let me make them green arcs so I can distinguish them from the blue arcs. These pictures do get a little messy, a little busy sometimes. That's why it's important to have multiple colors, or again, colored pencils would be helpful if you had those. All right, and I'll make these little blue dots. And draw a line connecting those. Where that crosses, that is the midpoint of AC, and I'm going to call it point E. All right, so we got point D and point E. Now, I haven't drawn a mid-segment yet. The mid-segment, which I'm going to draw as a red line, connects the two midpoints right there. That's the mid-segment. So let me write down a couple of notes here. Let's say that D is the midpoint of AB, and E is the midpoint of AC. And so what that means is DE is a mid-segment. Now, that's great, but it has some important properties. Two important properties about mid-segments. What do you notice about DE? Well, yeah, it's connecting midpoints, but look at DE compared to BC. What do you notice? And really, two things are what you should be maybe noticing. First of all, let's talk about length. Is BC and DE the same length? No, of course not. DE is much closer to point A is than anything. If anything, we're creating kind of a dilation thing here with similar triangles, which is a whole bunch of stuff you don't know about yet, but you will soon. But DE is not the same length as BC. DE is half the length of BC. So a mid-segment is half the length Now, how would I say that? Well, it's not just half the length. There is another relationship between DE and BC, and that is that they are parallel. DE and BC are parallel. They have the same slope. These lines, if I extend DE and I extend BC, they will never intersect. They'll never get closer and never get further away. They are parallel. So the mid-segment DE is parallel to BC. That's the symbol for parallel. Two vertical small lines. That's a parallel symbol. And we also know that DE is half of BC. It's half the length of BC. So if this is 10, this is 5. It's just half the length. So not only does a mid-segment connect two midpoints, but the most important definition of all is it is half the length of its parallel side. So a mid-segment is half the length of its parallel side. Now, if I were to draw on another one here, let's just estimate. Like, let's say that this is, BC somewhere. This mid-segment, well, it's parallel to AC, and it would be half the length of AC. So mid-segments are half the length of its parallel side, and it connects two midpoints. So because we're talking a little bit about length, there's a little bit of algebra involved, and this is a very short, very basic question. If DE is 15, and it's a mid-segment, well, then what's the length of BC? Yeah, you guessed it. Very easy. Double the length there, 30. The mid-segment is half the length of the side it is parallel to. Very easy. Now, what you'll see is some problems is, all right, well, this is x plus 2, and this is 2x minus 4. You'd have to create an expression. Well, you would say that, 2x minus 4 is equal to 2 times x plus 2, because you would have to double this length to set it equal to this length. But we'll see that stuff in class when we practice these problems. But the important concepts is that I got to find a couple of midpoints, and that's just our perpendicular construction that we've done many times, the bisector construction. Once you have a couple of midpoints, connect them to make a mid-segment, and that length is parallel to the side of the triangle that it's not touching, and it is half of that length. All right, so that's it for today, and we'll practice this later. See ya.